This video is sponsored by Squarespace.
I don't want to go all John Green on you guys, but the history of humanity is full of disease. Even when you pay attention in a history class, though, you only hear about a few headliner events. You got the Black Death in the 14th century, the Spanish flu, 1918, which actually was not Spanish in origin. That's not important right now, though. Pathogens like the influenza virus and Yersinia pestis, the species of bacteria responsible for the bubonic plague, have caused many epidemics and pandemics that you may have never heard about. And that's kind of inexcusable. So let's break down 7 of them across history and learn why they were every bit as awful as the famous ones. First, let's address the difference between an epidemic and a pandemic. In general, experts use the word epidemic where a certain geographic area sees an unexpected increase in cases compared to normal, while pandemic is used for skyrocketing increase over a broader population and location. But usually there's no clear-cut threshold for the exact number of cases that pushes an outbreak into either category. Public health officials just have to keep an eye on the typical disease numbers in an area and compare what they're observing now. With that little lesson out of the way, let's start with the oldest epidemic on our list, which features a virus we know all too well. If you're like most of our audience, you were born before the 21st century, and you've already lived through multiple coronavirus epidemics. But unless you look very, very good for your age, you definitely did not experience the first one. Because our earliest evidence of a coronavirus epidemic dates to around 23,000 BCE in East Asia. Now, of course, we do not have any first-person accounts, but to explore our ancient past, scientists can study our modern genetic code and kind of work backwards. In a study published in 2021, one research team looked at over 2,500 human genomes across 26 global populations to look for evidence of ancient coronavirus epidemics. Specifically, they were looking for parts of the human genome that code for certain virus-interacting proteins, or VIPs. And like that acronym suggests, VIPs are very important proteins, but not in a good way. For example, some are proteins on the outside of our cells that viruses use to attach to and infect them. So any evidence of VIP evolution could suggest some past viral epidemic caused the proteins to adapt. In other words, people with VIPs that the viruses couldn't latch onto as easily were more likely to not die before passing their genes on to the next generation. For this study, scientists were looking specifically at VIPs that are known to interact with coronaviruses, although that does not mean that they only interact with coronaviruses, hence my use of the word could. But based on the genetic evidence and some fancy computer models to estimate when certain mutations must have originated, the researchers found significant adaptation in coronavirus VIPs dating back roughly 900 generations. They also found that most of the oldest genetic adaptations seem to have happened in the ancestors of modern East Asian populations. Together, the evidence suggests that ancient humans in what is now East Asia probably experienced a coronavirus epidemic somewhere around 25,000 years ago. This is very cool that we can find evidence for epidemics that happened thousands of years before we could even write about them. But learning about the evolutionary history of humans' response to coronavirus can also help us improve prediction tools for future pandemics. And we know this was a bad pandemic because it doesn't change people's proteins unless a lot of people don't pass their genes on because they died. So yeah, I am always in favor of better tools for predicting and understanding future pandemics. But genomic signatures are not the only thing that can tell us about epidemics with very few contemporary sources. We can also look at mythology. We're jumping forward roughly 24,000 years to the 6th century CE in Wales for this one. A mysterious plague was sweeping across the country, leaving horrible recurring fever and death in its wake. The disease was known by many names, including Llywelyn in Welsh, Pestis flava in Latin, and the Welsh yellow plague on account of one characteristic symptom being jaundice. Despite taking place in the same century as the first official bubonic plague, the two were caused by completely different pathogens. Now, technically, scientists have not been able to fully confirm the pathogen behind the Welsh yellow plague, but based on our writer's hunt through the literature, one major candidate is a species of spiral-shaped bacteria called Borrelia recurrentis. This bacteria is carried by lice and causes a disease called relapsing fever. Whatever the source, this plague was so horrible and sudden Britain, it inspired a mythological yellow monster called Evadfelyn in Welsh legends. Perhaps adding to Evadfelyn's mystique is how it killed the King of North Wales, according to one admittedly much later recording of events, after a poet named Taliesin prophesied that a strange yellow monster would punish him for his crimes. The king did indeed die of the plague. Due to the great challenge of preserving and verifying poem prophecies from the 6th century, we are not 100% sure that Taliesin was the author of the prophecy, or that this prophecy was even made back then, but the legend has been compelling enough to withstand the centuries. The Yellow Plague also seems to have shaped human migration. The disease is probably at least one of the major drivers of a mass exodus out of Wales to Ireland and Brittany. If you've never heard of Brittany, it is now the northwesternmost part of France. Not its own kingdom, but all that plague-inspired immigration helped Brittany become so powerful it didn't get absorbed by France for another 1,000 years. And our next example is another case of disease shaping local human life for a whole millennium. Smallpox is probably most famous for being the only disease that humans have managed to eradicate. It was a global problem for at least 3,000 years, up until 1980. Smallpox likely came to Japan through merchants and Buddhist missionaries in, yet again, the 6th century CE, and the country's first recorded smallpox epidemic started in 735. Proportionally, the death toll of this epidemic was comparable to the Black Death. Roughly 1/3 of Japan's population was lost. So while it was only in one country, it was a very big deal for that country. We asked our resident Japan expert Haruka if she had heard of this epidemic before our script editor pitched the episode, and yes, she had. One interesting characteristic of this smallpox epidemic is that 95% of the deaths were in children under 10. In more modern cases of smallpox outside Japan, the disease doesn't seem to have discriminated so clearly. At the time, managing your child's smallpox within the household became a normal part of Japanese life. People even threw parties to celebrate children's recovery as an important coming-of-age milestone. Good idea. I mean, that's very sad, but I hope there was like a good cake. Meanwhile, to manage the disease, households also learned early public health measures. For example, in more rural areas where smallpox wasn't as common, people implemented isolation and quarantine measures. And you know who could also use some cake is the people stuck in quarantine. Maybe even more than the people who were finished with the whole I might die of smallpox thing. Quarantine cake sounds great. Norms like these developed over the centuries as dozens of smallpox epidemics came and went until the mid-1800s. And speaking of diseases that came back over and over again, when it comes to flu pandemics, the one from 1918 often gets all of the glory, which makes sense given that it killed 50 million people and infected 1/5 of the global population. But the first flu pandemic probably happened back in 1510, and it spread across Afro-Eurasia through trade routes. We actually have first-hand accounts of this disease, so we know that it came with the now familiar symptoms of a hoarse voice, fever, chills, and a phlegmy cough. In the 16th century, methods of treating influenza were pretty ineffective and unpleasant. People still believed in the four humors theory back then, which was based on the idea that illness was caused by an imbalance of fluids in your body. So making people vomit, inducing diarrhea, and bloodletting were all common treatments. And that just sounds bad. Thankfully, we now have flu vaccines and antivirals and chicken noodle soup. And speaking of thankful, we are also thankful to the folks who help us keep our lights on, which means it's time for an ad.
Thanks to Squarespace for supporting this SciShow video. You know Squarespace. It's the website place where you can manage online stores, payments, emails, and more. Our director, Haruka, uses Squarespace for her website. She even took advantage of the elevated suite of visual design effects that fit right into her site. Squarespace offers flexible templates with design intelligence using AI technology, so you can have your own professionally designed website. Plus, they curated videos on their own YouTube channel with tutorials to help you through the process. You don't even have to leave the site you're already on. For a free trial, head to squarespace.com. And when you're ready to launch, go to squarespace.com/scishow to save 10% off your first purchase of a website or domain.
When Spanish conquistadors arrived in Mexico in the 16th century, they brought a lot of terrible things with them, including diseases like smallpox, which the indigenous population had never encountered before. But the deadliest disease around that time was not smallpox, it was cocoliztli, which translates to pestilence in the Nahuatl language. And while some evidence suggests it too was brought over from Europe, there's not enough to definitely rule out it being homegrown. Cocoliztli is regarded as one of the most devastating devastating epidemics in human history. Within just 3 years, an epidemic that started in 1545 killed up to 80% of the indigenous Mexican population through sudden fever, painful ulcers all over the body, and excessive bleeding. Death usually came in just a few days. For a while, scientists weren't really sure which pathogen was the culprit. There were a lot of candidates, including those responsible for typhus, enteric fevers, measles, and of course, good old-fashioned plague. But a study published in 2018 suggests something that probably sounds a lot more familiar to you: Salmonella. For this research, scientists excavated 29 cocoliztli era skeletons in Mexico and isolated DNA samples from the teeth, which, I should clarify, does not have to mean human DNA. Because by sequencing the genomes and checking them against known sequences of bacterial DNA, the researchers were able to identify the presence of Salmonella paratyphi C, which is a strain that causes enteric fever. It's not the same kind of salmonella that your friend's cousin picked up from eating raw chicken or whatever. But despite this bit of evidence, we're still not confident that we have cracked the code on cocoliztli. According to historical indigenous accounts, some symptoms don't completely line up with the Salmonella hypothesis. For example, there are records of jaundice and bleeding from various body parts, and those aren't completely consistent with enteric fevers. But the scientists behind the 2018 study were only looking for DNA evidence, so that doesn't rule out any possibility of non-DNA viruses also being to blame. Or hear me out, maybe it's not a bacteria or a virus that's responsible, like our next epidemic example. In 1940, the southwestern US experienced an epidemic caused by a fungus called Coccidioides immitis. In general, the disease it causes is called coccidiomycosis. But since this particular epidemic happened in California's San Joaquin Valley, the disease behind it was also called valley fever, which is a lot easier to say, so I'm going to be doing that. During World War II, the US military wanted to train some troops in the San Joaquin Valley, which, if you've never been there, is a dry climate with lots of dust. Since fungi spread especially well in dry areas that can kick up dust and fungus particles, scientists already knew that there was a fairly high risk of valley fever. They also already knew that the fungus could cause skin lesions, headaches, chest pain, fever, and night sweats, depending on how you caught it. In more extreme cases, people could develop pneumonia and red, bruise-like bumps all over their skin. Despite the warning, the military decided that the benefits of the area outweighed the potential risks, so they went ahead with moving soldiers into the valley, and in response, the local scientists got to work with public health measures. For example, they had a skin test that identified if someone ever suffered from a bout of valley fever, even if they'd already recovered. And they suspected those people were unlikely to get reinfected. So when each soldier arrived, he got screened with a skin test. Anyone who tested negative would be periodically retested. With this systematic screening, scientists were also able to confirm that people whose skin test was positive did not get reinfected. Fortunately, the more scientists were aware of valley fever, the better they could prevent it. The incidence rate of valley fever started out around 25% among the military recruits, but with efforts to limit dust exposure, the rate of new infections dropped by half. Unfortunately, this wasn't the only damage valley fever dealt during this epidemic, because it was also spread through Japanese internment camps. And while some papers report just 30 cases of valley fever in those camps, we can be pretty sure that the disease was underreported there. The Japanese Americans who were incarcerated in dusty areas were especially vulnerable to valley fever and did not receive the same public health screening that the US soldiers had. Similarly, World War II prisoners of war were held in very dusty and dry military camps in Arizona, another hotbed for valley fever. Many of the prisoners were brought to Arizona specifically for its dry climate because they all had, guess what? Tuberculosis.
Oh, sorry, somebody talking about tuberculosis?
Having tuberculosis made those prisoners of war more susceptible to other infections, and there were at least 2 deaths from valley fever. We've learned a lot about disease prevention and management over the past century, but cases like this show how health resources are not evenly distributed. But to make sure we end on even more of a downer, let's look at a full-blown pandemic you probably have never heard of that is happening right now. When you think about early public health measures, John Snow's study of cholera, which he did in the middle of history's deadliest cholera pandemic, might be top of mind. After all, his groundbreaking work earned him the title of the father of epidemiology, which might not be as impressive as whatever John Snow did in George R.R. Martin's book about the wall up there. But I know he did some impressive stuff. Why are we talking about Game of Thrones? It's 2026. While Snow's investigation led to the successful control of cholera in London in 1854, that was not the last time the world would suffer a cholera pandemic. In fact, unless the World Health Organization announces otherwise after we have filmed this episode, we are currently in the middle of the 7th cholera pandemic. Cholera is a waterborne disease caused by a species of bacteria called Vibrio cholerae, and it is not just something that you can die of in the Oregon Trail game. This is a real disease. If you drink water contaminated with cholera, you could end up with severe watery diarrhea, which leads to life-threatening dehydration. Even though we've known about cholera for centuries and we know how to prevent it, cholera cases are still on the rise. The US might see only 20 cases a year or so, but in places like Afghanistan and the Democratic Republic of the Congo, we're looking at tens to hundreds of thousands. The disease still exists in large part because of the lack of clean water and proper sanitation facilities. In rural and impoverished communities especially, not everyone has access to indoor plumbing and sewage treatment plants that we know are super important for cholera prevention. We do have cholera vaccines, and vaccines, as you may have heard, are great at preventing disease spread. They are what helped us eradicate smallpox all those list entries ago. But there has been a global cholera vaccine shortage since 2022. So instead of the 2 doses a person needs for full protection, mass vaccination campaigns can only give out 1. While the vaccines do work to prevent cholera, the single-dose protection only lasts for about 3 months. And as if that weren't enough, climate change is adding fuel to this fire. The increase in natural disasters that come with climate change, like floods, droughts, and cyclones, devastate communities, further reducing access to clean water. Like I said, it's a downer to end on, but it's a good reminder that you don't just miss major disease outbreaks because your school's history textbooks failed to mention them. You can miss major ones you're living through right now that will probably get left out of future history textbooks too. Kinda makes you feel a little sick, doesn't it?